Hi guys, this is Vicky here, and we are going to go through the final question for the 2014 AP FRQ questions, question number 7. So it says the half-life of the catalyzed isomerization of cis-2-butene gas to produce trans-2-butene gas represented above was measured under various conditions as shown in the table below. The reaction is first order. Explain how the data in the table are consistent with first order reactions. So if you guys remember first order reactions, they are directly proportional to each other, right? So as time passes, a consistent amount of time passes, the mass halves or doubles, right? So if you look over here, the time is consistent. Do you see that? As long as the temperatures are consistent, the time is consistent. So that tells me that A, okay, it's first order because the half-life is independent, okay, to reactant concentrations. Okay, it doesn't matter if the concentrations are changing, the half-life is consistent through trials 1, 2, and 3. Okay, all right, let's continue to B. Calculate the rate constant for K for the reaction at 350. Include appropriate units for your answer. So this is actually, the formula has been given to you. Okay, the formula for K for first order is 0.693 over the half-life. Okay, so it's 0.693 and the half-life is what? 100 seconds, right? So if you do the math, you end up with 0.00693 per seconds, right? And that is going to be your K value. Okay, all right, C. Is the initial rate of the reaction, okay, in trial 1 greater than, less than, or equal to initial rate of trial 2? So it looks like the initial rate of, look at this, look at the concentrations. The concentrations are changing. It went from 300 to 600. So the initial concentration has changed. Therefore, the initial rate of trial 1 is going to be less than that of trial 2. Okay, so if you look, remember, what is the rate law? Rate is equal to K, okay, and this is the cis-2-butene, right? And if you look, the rate has changed because trial 1, it was 300, whereas trial 2 was 600, right? So therefore, trial 1 is less than trial 2, the initial rates, okay? All right, D. The half-life of the reaction in trial 4 is less than the half-life in trial 1. Explain. So if you look at the temperatures, here the temperature changes from 350 to 365, right? Because temperature changes, okay, we can say higher temp in trial 4. This just means that the molecules are moving faster, okay? Molecules have larger kinetic energy as they are moving faster, and therefore it has a greater collision frequency, okay? Has higher collision frequency. It's able to collide more frequently, and thus the rate is larger, okay? Rate is greater. Okie dokies? Okie dokies. All right, comment below. Let me know what other videos you guys want to see, and I will post them. All right, have a nice day. Bye, guys.